This is 5.1 quadratic functions in vertex form. So vertex form is just a way to write out a quadratic equation where it is easy to identify the vertex, okay? And it is y is equal to a times x minus h squared plus k, right? And the graph of a quadratic equation is a parabola, so it's going to be U-shaped and it's curved, not straight. The parent function is the f of x equal to x squared, and a cannot equal 0. All right, so the vertex is the lowest or highest point on the parabola. You'll also hear it referred to as the maximum or minimum. So if we have a parabola that opens upwards like we have here, then the vertex is going to be the minimum. If it opens downwards, then the vertex is going to be the maximum. And the axis of symmetry divides the parabola into mirror images and passes through the vertex. So for this example that we have here, the axis of symmetry is going to be right here, passing at x equals 0. Now let's look at some properties of quadratics in vertex form. Let's go ahead and rewrite this out here. So vertex form is y is equal to a times x minus h squared plus k. All right, and the vertex is going to be h comma k. Remember, like the h is a little confusing because in here it's negative h, or you can think about it as the opposite of h. So when you're looking for the vertex, it's always the opposite of what's inside your equation. All right, and the axis of symmetry is where x is equal to h, and x is a vertical line. Okay, and if a is greater than 0, what happens? Let's go ahead and switch over to Desmos. Okay, so now I'm on desmos.com. I've got the vertex form of the quadratic equation graphed out here, and I have the h and k values set to 0 and the a value equaling 1. So this is essentially the parent function written out a different way. All right, so what happens if the a value is greater than 0? So 1 is greater than 0, so it opens up. What if the a value is less than 0? So let's go and make this, I don't know, -1. Okay, as you can see, it opens downwards. And if we change this, let's just make it 10, okay, it's still going to be down. All right, so let's go back to our note and write that down. So if a is greater than 0, the parabola opens up. And if a is less than 0, right, if it's a negative number, it is going to open downwards. All right. Okay, so now if the absolute value is greater than 1, let's see what happens. So the absolute value being greater than 1. So let's just go with 2. All right. It looks a little bit more narrow than the parent function. Let's go with 10. All right. So if we have the absolute value, and it's not just in the positive direction, if I make this -10, well, the absolute value of -10 is +10, so it's greater than 1. So if that's the case, it would appear that the parabola is going to be more narrow than the parent function. So let's go ahead and write that down. So if the absolute value of a is greater than 1, the parabola will be more narrow than the parent function. Okay, and if the absolute value is less than 1, so let's jump back over to Desmos. So if it is less than 1, the absolute value, so we're basically talking about a decimal here. So if we have 0.1, okay, look at that. It looks like it's much wider than the parent function. What if we make this an even smaller decimal? Let's add a 0 in front. Okay, makes it even wider. Add another decimal, super crazy wide, it looks like. All right, so mess around a little bit here. 0 0.4, that's definitely wider than the parent function. 0 0.7, wider. Okay, so there we go. It looks like if the absolute value of a is less than 1, then the parabola will be wider than the parent function. Okay, so now let's look at some examples here. Why don't we start with y is equal to x plus 3 squared minus 4. Okay, so we should, I don't know why we have this as axis of symmetry first and then vertex. You should start with trying to find the vertex. Remember, vertex is h comma k, but remember it's the opposite of h. So the vertex is going to be -3, and then the k is more straightforward, right? It's just whatever the k value is. So my vertex is going to be -3 comma -4. So let's plot that out. 1, 2, 3, 4. Looks like the vertex is going to be right there. And the axis of symmetry is going to be whatever x is equal. So it's going to be x is equal to -3. And so I'll just make a dashed line right here. That is your axis of symmetry. Okay. All right. Now, how do we plot this out? So one thing we can do is just pick some values. Okay. And so we can see that the vertex is here at -3, -4. My a value, it's not written, but my a value is equal to 1, right? It's a positive 1. So we know this parabola is going to open upwards. Okay. So why don't we pick -2, -1, and 0. It would make sense that we should be able to find some corresponding y values still on this graph that we have here. Okay, so if we do that, let's start with -2. So let's take our equation and substitute out x with -2. All right, so and then we just simplify. So we have -2 plus 3, that is 1. 1 squared is 1 minus 4 is -3. So when x is -2, my f of x or my y, same thing, is -3. Okay, so that means I have a point at -2, -3. Down 1, 2, 3. And look at that. Okay, and so remember, the axis of symmetry creates a mirror image. So if I have a point that is one spot away to the right, then I know that I need to go one to the left in the other direction because of the axis of symmetry. Okay, so now let's plug in x being -1. So y is equal to -1 plus 3 squared minus 4. -1 plus 3 is 2. 2 squared is 4. 4 minus 4 is 0. All right, so if I go back 1, up 0, looks like that's right here. And again, if we're 2 spots from our axis of symmetry, we go 2 spots in the other direction, and I'll have a point right there. Okay, how now 0. So I'm going to put that here. Y is equal to 0 plus 3 squared minus 4. 0 plus 3 is 3. 3 squared is 9. 9 minus 4 is 5. All right, so let's plot that out. I'm going to go over 0, up 1, 2, 3, 4, 5. Okay, and again, I'm 3 spots away from the axis of symmetry to the right. So if I go 3 spots to the left, 1, 2, 3, there will be another point there. All right, so here is my parabola. Remember, guys, I'm drawing on this pad on my computer. I'm not very good at drawing lines. Okay, so I'm sure you can do a lot better than that. Okay, so there we go. We have this parabola quadratic function graphed out for us. All right, let's try another one. Okay, I'm gonna change my pen color up for this one because I'm gonna use the same graph. Why don't we try y equals -2 times x minus 4 squared plus 8. All right, so let's start with the vertex. Remember that is h comma k. So it's the opposite of h. H is -4 in there, so we want +4, 8. All right, so where's that at? We go over 4, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Looks like that's right there. There's our vertex axis of symmetry. The x is equal to 4. So we can do a dashed line here for our axis of symmetry. All right, and so there's a bit of kind of just guess and check here when it comes to picking numbers for our x values. So if I go with 0, I don't think 0 is going to be a good number to pick, and I'll show you why. So if we go ahead and we put 0 into the equation, y is equal to -2 times 0 minus 4 squared plus 8. Well, let's see, if we go ahead, 0 minus 4 is -4. Go ahead and square that, we get 16, positive 16. Positive 16 times -2 is -32. -32 plus 8 is still -24. Okay, so if we look at that, where x is at 0, so that's right here, the corresponding y value isn't going to be until -24. And it looks like we stop here at -10 on the y-axis. So that's why there's a little bit of science to the picking the correct numbers. So I'm going to go ahead and change this. Why don't we go with 1, 2, and 3 and see if these are a little bit better for us. So let's start with 1. If I plug this into the equation, -2 times 1 minus 4 squared plus 8. 1 minus 4 is -3. Square that, we get 9. 9 times -2 is -18. -18 plus 8 is -10. Okay, so this one might be a little bit better. So when x is 1, the f of x is -10, or the y is -10. So that means we're at over 1 down 10. So that is going to be right here. All right, and remember, we're 3 spots away to the left of the axis of symmetry, so we can go 1, 2, 3 spots over to the right, and that's going to be another one of our points. All right, now let's put in our next x value. Y is equal to -2 times 2 minus 4 squared plus 8. 2 minus 4 is -2. -2 squared is +4. -2 times +4 is -8. -8 plus 8 is 0. So when x is 2, the f of x is 0. All right, so that means I'm going to go over 2, up none. There's one of my points. Again, I'm 2 spots away to the left of the axis of symmetry. So if we start in the axis of symmetry and go 2 spots to the right, there will be another point. And let's get one more in here. y is equal to negative 2 times 3 minus 4 squared plus 8. Negative 3 minus 4 is negative 1. Negative 1 squared is positive 1. Negative 2 times positive 1 is negative 2. Negative 2 plus 8 is positive 6. All right, so when x is 3, y is 6. So let's go over 3, up 1, 2, 3, 4, 5, 6. And it looks like we're going to be going over 1 to the right of the axis of symmetry. And there we go. There is our parabola quadratic function graphed out. Okay, so I showed you the hard way to graph out these quadratic functions. And now I'm going to show you this graphing shortcut, which makes it way easier. Okay, so the 135 graphing shortcut is when we multiply the a term by 1, 3, and 5. Okay, so for example 3, the a value, the a is the value in front of the parentheses. So my a value for number 3 is negative 1. Okay, so we're going to multiply negative 1 by 1. We're going to multiply it by 3 and 5. All right, so we get negative 1, negative 3, and negative 5. All right, so we first need to find the vertex, which we know how to do because it's in vertex form, so it's super easy, right? It's h comma k. The h is the opposite, so this is negative 6, positive 2. There is my vertex. So let's plot that out. 1, 2, 3, 4, 5, 6. Went back 6, up 2. Looks like that's right here. And now, all we need to do is go over 1, down 1. Over 1, down 3. 1, 2, 3. And over 1, down 1, 2, 3, 4, 5. Okay, and remember we have the axis of symmetry. So we can double our points by just going in the opposite direction, right? We're one spot away from the axis of symmetry here, 2 spots here, so we can go 2 in the other direction, and 3 in the right direction here. 1, 2, 3. So look at that, we double our points. Much easier and quicker to graph these out using this shortcut. All right, there we go. Connect the points with a curved line on both sides, and there you go. All right, I'm going to switch up my color here. So my a term for number 4 is 1/2. So we're going to take 1/2 and multiply it by 1, 1/2 multiply it by 3, and 1/2 multiply it by 5. All right, so 1/2 of 1 is 1/2, right? Or 1 times anything is itself. 1/2 times 3 is 1.5, and 1/2 times 5 is 2.5. All right, so this is how we're gonna plot these out. Let's find the vertex. The vertex is gonna be opposite of h, so 2, and negative 3 is k. So let's plot this out. We're gonna go over 2, down 3. Looks like that's right here. Our a term is positive, so I know this is gonna be going up. It's gonna open upwards. So I'm gonna go over 1, up 1/2. I'm going to go over 1, up 1.5. So here's 1/2, here's up 1, right there. And then over 1, up 1, 2.5, and there we go. All right, axis of symmetry is right here. So I can double our points by going in the opposite, right? Kind of reflect this thing. So I'm going to have a point here. I'm going to have a point right there. And 3 spots away to the left, 1, 2, 3 would be right there. And there we go. It's as easy as that. Connect the points with our line, and there we're set. All right, number 5, I'm going to switch colors again. We'll do black this time. All right, so my A value is 3. So I'm going to do 1, 3, and 5, multiply it by 3. 3 times 1 is 3, 3 times 3 is 9, and 5 times 3 is 15. Okay, so this one's a little bit tricky. What is my vertex? Well, I don't have a value in parentheses, so that means my h value is going to be 0, and my k is the -8. Okay, so here's my vertex at 0, -8. 0, -8 should be 1, 2, 3, 4, 5, 6, 7, 8 right here. We have a positive A value, so we know this is going to open upwards. And now we can just follow our 135 graphing shortcut. So we're going to be going over 1 up 3, over 1 up 9, and over 1 up 15. We're definitely not going to get this third one, the third point graphed out on here, but that's okay. Try to fit as many points as you can. So I'm going to go over 1 up 3, 1, 2, 3. And you can kind of just do this in one step. You can go, if you know that the axis of symmetry is basically going to be the y-axis, you can go in the opposite direction to create the mirror image right away. Okay, now let's go over 1 up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm 2 away from the axis of symmetry, which is the y-axis. So I'm going to go 2 to the left, which will be 1, 2, right there. And obviously going over 1 up 15 is going to be way off the graph. So I'm just going to stick with these. And there we go. You see we've got the A value greater than 1. So it is going to be narrower than the parent function. And that shows. Moving on, example 6, tell whether the quadratic has a minimum or maximum value, then find that value. Okay, well, let's start with the A value, which would be 3/2. Okay, so this is positive, and we know if the A value is positive, the parabola will open upwards, so it will have a minimum value. Okay, and that minimum value will be the vertex, so this point right here. And how do we find that value? Well, it's just going to be the vertex, which is h comma k. Remember, h is the opposite, so it's going to be +5, +6. All right, easy as that. Remember, if it opens up, it's a minimum value. If it opens down, it's going to be a maximum value. All right, moving on. Example 7. Bean Skywalker started as a pilot and was always kind of cocky. Upon returning from a patrol, he requested a flyby. He gave the tower the equation of y is equal to 1/25 times x minus 45.6 squared plus 8.5 as a vector for his approach. How close will Bean Skywalker be to the ground on his flyby? And sketch a rough graph of what his flyby might look like. Okay, well, again, this is going to be really rough, but here's my y-axis, here's my x-axis. We know that this is going to be a very wide looking parabola because the absolute value of A is less than 1, right? Because this is a fraction, so it's less than 1. So this is going to look something like this, right? It's going to be a fairly wide looking parabola. And so if we look at the vertex, right, the vertex being hk, so we're going to be at +45.6, and we're going to be off the ground 8.5. Okay, so there we go. I think we have our answer already. So how close will Bean Skywalker be to the ground on his flyby? He will be 8.5 feet off the ground. All right, so see, look at that. Word problems are not always that hard. Super easy to do that one. All right, Numbers 1 and 2. Why don't you go ahead and pause this video and try to graph these out. All right, let's see how you did. Number 1, we're going to start with the vertex. Let's find the vertex. It's going to be +4, +7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. That's right there. And you could definitely take your time to make a table, but I'm just going to take my a term, which is -2, and multiply it by 1, 3, and 5. So I'm going to get -2, -6, and -10. So I'm going to go over 1 down 2, 1, 2. I'm going to just write my axis of symmetry so that way I can double my points up. There'll be a point right here as well. Over 1 down 1, 2, 3, 4, 5, 6 means I'm going to have a point 2 spots away from the axis of symmetry to the right, and down 10. That'll be just about over here. I'm going to plot it out anyway. Over 1 down 10 should be about right here, and that means I should have another point about right there. So there we go. Hopefully yours looks fairly similar to mine. And number 2, tell whether the quadratic has a minimum or maximum value. Well, the a term is negative, so this is going to be opening downwards. And find that value. Well, this point will be at 102, 52. There's your vertex. All right, that's all I got for you guys. Why don't you give the practice problem a shot? If you need help, watch my video. If you still need help, come see me. Good luck.